Coral reefs are among the most valuable ecosystems on Earth, forming massive, complex habitats for thousands of other species. They are one of the most diverse ecosystems on Earth and hold a variety of living species greater than any other shallow water marine ecosystem. As our anthropogenic activities have caused a climate change, ocean levels are rising and temperatures are increasing. Coral does not respond to temperature inflections well, and this global warming is causing coral bleaching. Higher temperatures in the water also increase the occurrence of other coral diseases, including the black band disease, white band disease, white plague, and white pox. These can all lead to a huge disappearance of coral and possibly the entire ecosystem. The world's oceans cover 2/3 of the planet's surface. Is it possible that humans are changing the chemistry of the oceans? We have heard that carbon dioxide levels are steadily rising as a result of human activity, like the burning of fossil fuels. This graph shows CO2 levels measured at the Mount Loma Observatory in Hawaii from 1958 to 2008. One effect of this increase in CO2 is global warming. Another equally worrying effect is ocean acidification. Gases in the air naturally come into equilibrium with gases in the water. As CO2 concentrations increase in the air, they also increase in the water. When the CO2 thus enters the ocean, it combines with water molecules to form carbonic acid. In simple terms, this increase in acid can be thought of as what actually causes acidification. In reality, the change in pH itself is a result of the H+ ions that are released as carbonic acid naturally breaks down into bicarbonate and carbonate molecules. The increase in hydrogen ion concentration leads to an increase in acidity. With extra hydrogen ions around, the equilibrium reactions shown on the right side of the figure are shifted towards bicarbonate. This happens because the excess hydrogen ions tend to combine with carbonate to form bicarbonate. In summary, excess CO2 leads to lower pH, higher bicarbonate levels, and lower carbonate levels. Calcium levels remain stable, but with less carbonate around, less calcium carbonate can be formed by organisms that make their shells from calcium carbonate. This can lead to weaker shells, slower growth, and is a great cause for concern.
I am coral. Some people think I'm just a rock, when in fact I'm the largest thing alive on this planet. I'm so big I can be seen from space. But for how long? I grew for almost 250 million years. Then humans came along and now 1/5 of me is gone. Sure, I live at the bottom of the sea, and you might not see me that often. But you do need me. Do you realize that 1/4 of all marine life depends on me? I am the nursery of the sea. Little fish depend on me for food, and to hide from the big fish. And guess who eats the big fish? That's right, you do. I'm the protein factory for the world. Yet you raise the temperature of the ocean so I can't live here anymore. And when big storms and tsunamis barrel through the ocean, I'm your fortress. Yet you tear me apart with dynamite and poison me with cyanide. Well, here's a crazy thought. Stop killing me.
Cyanide fishing is one practice that is killing live coral and the reef organisms that sustain it. Cyanide fishing is a practice in which sodium cyanide is sprayed into the marine ecosystems in order to stun and capture fish, either for aquariums or to fulfill the growing demand for live fish food. It is considered a faster and easier method than fishing the old-fashioned way, which is either by net or hook and line. Unfortunately, more fish are captured than are needed. Cyanide is poisonous to coral reef organisms, killing both coral and non-target fish. Cyanide is blighting our beautiful marine ecosystems. Spreading the word about cyanide fishing and contacting your government about this harmful technique can help us put laws in place and make it illegal to use cyanide, which is killing millions of excess fish. Not only is cyanide hurting our reefs, but also nutrient runoff is a very important factor.
Land has an enormous effect on the ocean. For instance, as the world's population grows, we're demanding much more from our farmland. We're applying more and more fertilizer, which contains nutrients like nitrogen and phosphorus to increase food production. However, too much fertilizer on farms and on lawns and gardens is a problem. Why? Because when we use too much of it or apply it in the wrong place or at the wrong time, plants can't absorb it all. These excess nutrients get washed into streams and rivers and eventually into the ocean. This process is referred to as nutrient runoff. Fertilizer in the water makes algae grow. A bountiful crop on land might be a good thing, but a bountiful crop of algae in the water can be a disaster. Here's why. Excess algae block the sunlight that aquatic life needs to survive. Some algae also release toxins that impact human health. Worst of all, when algae die and decompose, they consume all the oxygen in the surrounding water. This results in widespread fish kills and habitat destruction, creating so-called dead zones. Enormous dead zones in the Gulf of Mexico and the Chesapeake Bay have already had an impact on the health and economies of people living there, costing the United States an estimated $2.2 billion annually. And the problem keeps growing. Dead zones have increased around the world from 10 in 1960 to 405 in 2008. Fortunately, there are things we can do to help. If you have a yard or garden, use fertilizers in moderation and consider planting more native species, which require less fertilizer. Consider buying organic food. If you're a farmer, look for alternatives to phosphorus and nitrogen-based fertilizers, and use fertilizers more efficiently. Consider using cover crops as nutrient filters and buffers to reduce runoff. If you're a decision maker, you can put in place measures that improve the management of nutrients.
Oil spills are also a very prominent issue. Oil spills are threatening our reefs in their coral reproduction, growth rate, colonization capacities, feeding, and behavioral responses. Once oil comes into contact with corals, it can also kill them or impede their behavior and development. Oil can reach our coral reefs by direct contact at low tide, rough seas mixing the oil in ocean water, or mixing with sediment to make the oil denser and sink to the ocean floor where it can smother corals. The entire reef ecosystem can suffer from an oil spill, affecting the many species of fish, crab, and other marine invertebrates that live in and around coral reefs. We must find safe, non-harmful ways and a faster response to clean up these disasters. We must find ways to stop destroying our ecosystem by adequately financing and enforcing existing marine protected areas, eliminating destructive fishing practices such as dynamite and cyanide fishing, preventing erosion from inland farms, and reducing marine-based pollution from offshore oil operations. Our marine ecosystems deserve to be enjoyed for many years to come. By altering how we currently treat our coral reefs, we can improve the health and beauty once again. Let's save the home of our beautiful marine life before it is destroyed for good.